This is section number 8.3, testing a claim about a mean. Okay, in section 8.2, we discussed about testing a claim about a proportion. Now we have another population parameter, its mean. Now I am going to tell you how to test a claim about mean. Okay, in here we have two sections. Okay, the first thing is when sigma known. If you know the sigma, that means if you know the population, uh, if you know the population standard deviation, then you have to use this formula to claim for mu. Okay, so please remember, you cannot use this formula without knowing your sigma, that means population standard deviation. If you know population standard deviation, use this formula to find test statistic for claiming mu. Okay, then here x bar and mu and sigma and you know all the values, so we can substitute, then we can get the test statistic. Then we can use standard normal distribution to find the critical values and p values. You remember, because in previous section also we discussed about these things, how to find critical value and p value. You have to do the same thing in this part also. So there are two methods, critical value method and p value method. We can use both methods in here in this section also, in this part. When sigma known part, we can use those two methods. So use the standard normal table to find critical values and corresponding p values. Um, then next slide is slide number 39. We have two examples. I will tell you how to do these examples. Then you can understand how to claim a mu. Okay. Uh,
Okay, first example is athletic shoes, page number 39. Okay, first read the question. A researcher claims that the average cost of men's athletic shoes is less than $80. So that is the claim. So first write down the hypothesis. Here we have H0 versus H1. What is the claim? It's about, yeah, this section is about mean. Okay, here also you can see you have that nice keyword average. Okay, in here you can see any percentage, proportion, p, nothing. Here you can see only averages, standard deviations, those things. So if you see those keywords, it's about testing a claim about mean. Okay, so here it's mu. Shoes is less than, another keyword, 80. Okay, so that is my H1. So how can we write null? Mu is equals to 80. Same thing but with equal mark. Okay. Then next thing, write down the information. Okay, he collects a random sample of 36 pairs. So what is our N? 36. Then find that average cost is 75. Average cost x bar is 75. We have that value also, 75. Okay, now we have everything. So first thing you have to find critical value. What is, sorry, test statistic. Okay, not critical value. Okay, test statistic. First thing you have to find test statistic. What is the formula for test statistic? For this case, before that, read the whole question. Okay, assume the standard deviation of the population. Sigma is 19.2. That is very important. If you know sigma, you have to use this formula. Okay, If you don't know sigma, you have another formula. So it's very important to recognize whether you know this value or not. If you know population standard deviation, use this formula. If you don't know population standard deviation, use our next formula. Okay, but here it says assume the standard deviation of the population is 19.2. So we have all the information. Now write down the then of substitute values in here. What is our x bar? It's 75. What is our mu? Mean, population mean, it's 80. Then what is our sigma? 19.2. What is our n? 36. Take the square root. So what is our test statistic? It's negative 1.56. Okay, so this is my test statistic. Okay, now next thing. You have two methods. Either you can use critical value method or you can use p-value method. Okay, I will use both methods. But before that, what is our alpha? I will write it here. Okay, it's 0.10. Okay, now I will use first method. I will use critical value method as my first method. Do I have to write this? Okay, first method is critical value method. Okay, in here, according to this method, first draw the picture. We have left tail test. Okay, then what is our significance level? It's 0.10. Here, please remember, we don't have two tail test. Okay, so we have only one rejection region. It's in our left side. So it's our significance level 0.1000. Now, according to this area, find this value. What is that value? This is my rejection region. So that will be this is my critical region or rejection region. So this is my critical value. So we need this negative z-score table. Why? Because it's about negative z-score. The value, the closest value, we can't find exact value, but the closest value to 0.1000 is 0.1003. So what is the corresponding z-score? Negative 1.28. It's negative 1.28. Okay, here it's here, negative 1.28. Okay, now we have the critical value. Okay, so this is my critical value. I will write it here. Okay, critical value is negative 1.28. Okay, now mark your test statistic. In here it's negative 1.5. That means it's here. Negative 1.56 is what? Less than negative 1.28. Okay, so it's definitely in this rejection region, this colored area. So can you see? So our test statistic is less than our critical value. So we can say, what is the conclusion? We reject H0. We reject, where I will write it here. Reject H0. Okay. Now, using p-value method, I will show you how to do this one. Again, draw the picture. Middle is 0. Now we have negative test statistic. First mark it in here. According to p-value method, you have to use your test statistic. Negative 1.56. Then if it's left tail test, if you want to find p-value, What is that? The area to the left of your test statistic. So you have to find this colored area. It's easy because table always gives left-sided area. So according to negative negative 1.56. Negative 1.56. What is the area? 0.0594. 0.0594. 0.0594. That is the left-sided area. Using test statistic, we got that area. Okay. What is this area? That is our p-value. P means probability. Probability means area. So what is our p-value? It's 0.05. It is this colored area. Okay, 0.0594. Now compare it with your alpha. What is our alpha? This. Now, yes, this side. P-value is less than our alpha. So, if p-value is less than alpha, what is the conclusion? According to that slide number, we have to reject H naught. Okay, so can you see using first method and second method, we got the same conclusion. Reject H naught, or here also reject H naught. But in the exam, don't use both. Use only one method. Okay. Then what is the interpretation? I will write it in separate paper. Okay. Okay. Reject H naught means you can say we have enough evidence to support the claim. Okay. I will write it here. We have enough evidence to support the claim that the average cost, the average cost of men's athletic shoes is less than $80. Okay, so this is the interpretation. Very nice interpretation. Here we reject H naught. So reject H naught. So this will be. So this is wrong. This is correct. We reject H naught. So H1 can be correct. That's why we have enough evidence to support our claim that what? The average cost of men's athletic shoes is less than 80. Okay, so that is the final answer. Okay, now we have another example.
Okay. Yes, we have that is the answer for slide number 39, athletic shoes. Now we have another example. It's tuition. Now I will show you how to find how to how to get the result. Okay, I will show you how to get the result.
This is slide number 40, example tuition. First read the question carefully. The average expenditure per student for a certain school year was $10,337 with the population standard deviation of $1,560. Okay. Okay, now you know what? You know population mean and population standard deviation. Okay, when you read the question, you can recognize those parameter values. So write down those values first. What is our population mean? It's $10,337. Then what is our population standard deviation? It's $1,560. Okay, in here you know these two values, so here we know sigma. Okay, so you know, if we know sigma, you have to use one formula for mean, and if you don't know sigma, you will have another formula. Okay, but in here we know the value of sigma. Okay, then a survey for the next school year of 150 randomly selected students. So our sample size is 150 students, result in a sample mean of so we have the sample mean also. Okay, sample mean of, that is x bar of $10,798. Okay, no, this is my information. We have all the things. Okay, all the necessary information. Then what is the question? Do these results indicate that the average expenditure has changed? Okay, that is our question. When you read that one, we cannot see any keyword like increase, decrease, or greater than, less than. Okay, no, we cannot see those keywords. But here we can only see is what? It asks, do these results indicate that the average expenditure has changed? Change means it can be increasing or decreasing anyway. Okay, change means it can be anything. Anything can happen. Okay, so in this case, our claim goes with not equal sign. Okay, so first you have to write your hypothesis. If it's a hypothesis, then we have null hypothesis versus we have alternative hypothesis. In this question, it's about average, mean. So definitely population parameter is mu. Then you know, equal mark always goes with null hypothesis. Here, according to the claim, we got that it should be not equal. Why? Because it asks about the average expenditure has changed, so it can be increasing or decreasing thing. So we have to write not equal mark. Then what is our hypothesized value? It is our mu. Here we already have that value. Mu is equals to this value. So mu is equals to 10,337. Here same value. It is our hypothesized value. So this is my hypothesis. Okay, now next thing. First step is write down the hypothesis. Second step is you have to find the test statistic. If you know sigma, we have this formula for finding test statistic. Okay, it is in slide number 38. Okay, so it is x bar minus mu divided by sigma divided by square root of n. This is the formula. Now substitute values here, because we know everything. What is our x bar? It is 10,798 minus, what is our mu? 10337 divided by, what is our sigma? 1560 divided by, what is our n? 150. Take the square root. So what is our test statistic? What is the value for z? We will get this value. Okay, check. This is the value. Our test statistic is 3.62. Okay, now we have test statistic. Now the next step is you can use either critical value method or p-value method to find your critical values or p-values. But I will show you both methods. Okay, but if you are doing example, you don't need to do both. You don't need to show both methods. Okay, use only one method and get the relevant value. Okay, first, okay, I will write first method as critical value method. Critical value method. First, I will find what are the critical values using this critical value method. Okay, the first thing here, if it's about critical value, what we need significance level. Here it says use a 1% significance level, that means 0.01. Okay, then you have to remember, okay, this is two-tail test. So the whole critical region is alpha, it's 0.01. Then okay, I will draw the curve. If we want to find critical values, we want to know whether is this one tail, two tail, or sorry, one left tail, right tail, or two tail. But here it's two tail test, so definitely it has two rejection regions. Okay, so alpha is 0.01, so alpha over 2 is what? We had divided by 2, so it will be 0.005. So that is our alpha over 2. According to critical value method, these colored areas are our rejection regions, critical regions. So if we have two sides, one side should be alpha over 2. Okay, here also it's alpha over 2. So what is the value of our alpha over 2? It's 0.0050. In this side also it's same, 0.0050. Okay, then okay, now we have to find this point and this point. Those are our critical values. Okay, according to this method, the first thing you want to find your critical values. Okay, now using, in here we have two critical values. Why? Because we have two-sided test. So we need to find those critical values. Okay, I will use table to find these two z-scores. Those are our critical values. In here we know the critical regions, so we can find critical values. First I will use negative z-score table. Why? Because here you will get a negative z-score. Okay, so the area to the left is 0.0050. A special one. It's here. In this point, here we need 0.0050, but we cannot get that exact area, but we have closest two close values. One is 0.0051, other one is 0049. So you have to pick the middle of these two areas. According to that, it's a special one. Okay, there is a line, so the answer in the bottom of the table. Okay, here the second one. The area is 0.0050. Yes, our area is same as this area. So according to that area, what is the z-score? Negative 2.575. So the z value of this point, negative 2.575. This point, okay? Then using symmetry, you can find this point also. If this is negative, then definitely this is positive. Also here, middle is 0, so the right side always will be positive. Okay, so now we know what are the critical values. Using these critical regions, we got these two critical values. So I will write it here. One critical value is negative 2.575. Other critical value is positive 2.575. Okay, now we have critical values. Then, okay, now you have to do is check your test statistic with your critical values. Okay, our test statistic is 3.62. Now, what are the critical values? 2.5 and 1 is negative. But here don't need to check negative side. Why? Because we have positive value. So definitely your test statistic will be here, like 3.62, because if here it's 2 point something, so definitely it is right to your test critical value. So definitely it is in the critical region, rejection region. So your test statistic is in the rejection region. Okay, so what we can say, if your test statistic is in rejection region, means we have to reject H naught. So that is the answer. Okay, reject H naught. Then I will get the same answer using next method. Then we will write the common conclusion. Okay, how can we use second method to get this same conclusion. Same result. I will show you how to do that. Second method is p-value method. Okay, p-value method. How can we get the p-value according to our example? Here, the first thing, we know our test statistic. It's here. We need that one. It's 3.62. Then, according to p-value method, the first thing, draw the curve. This is two-tail test, okay? We have two sides, but we have positive test statistic. Mark it in here. It's a positive value. Then draw a line. If you have positive value, you have to find the area to the right, okay? You have to find this area. Then how can we find p-value? If you have two-tail test, then definitely there is same area in other side. That means you have to multiply this area. We need to find this area. Then you have to multiply that area by 2. How can we find this right-sided area? We know this z-score. It's 3.62. That means what is the corresponding area? If you have right-sided one, we cannot use table. So you have to find the left-sided area. That means the red colored area, this area. According to this z-score, we can find this area. What is the value of this area? 3.62. We have z values up to 3.4. After that, there is a line. It says 3.5 and up. If you have z scores 3.5 and up, then you have to get this area. It is same, okay, for the values great 3.5 and greater than 3.5, the z values. And then you have the same area. So what is the value of the area of this red color part? It's 0.9999. So that is the value of this red colored area, okay? But according to the example, we want to find what? I will write here, okay? Right-sided colored area. The whole area is 1, then subtract this red colored area. It's 0.9999. So what will be this small part? The area of this right-colored the area of this right-sided part, the black color area, it is 0.0001. So now we got the value of this right-sided part. Okay, how can we get p-value? P-value is the area to the right of the test statistic times 2. So the area is 0.0001. Okay, so what is our p-value? This is my p-value. Here we have two-tail test. That's why you have to multiply it by 2, okay? I told you how to find p-value if you have a two-tail test, okay? I can remember the slide number. I think it's in slide number 29, okay? In there it says if you have two-tail test and if you have positive test statistic, you have to get the area. You have to find the area to the right of the test statistic, then multiply it by 2. So this is our p-value. Now compare it with your alpha. What is our alpha? It's 0.01. 0.01. Now tell me what is the larger value, p-value or alpha? What? Alpha. Alpha is larger than our p-value. So p-value is smaller than alpha. Then according to that rule, it is in previous slide also. Slide number 28, okay? According to that, if you have a p-value less than alpha, the answer should be this, reject H0, okay? If you have any p-value less than the significance level, you have to reject H0. Okay, so can you see, using previous method also we got the same result, reject H0. Now also we got that result, reject H0. Now we can write the common conclusion, okay? What is that? We can say this way. We have enough evidence. We have enough evidence to support the claim that the average expenditure, claim that the average average expenditure per student has changed from 10,332 dollars. Okay, 37. Yeah. Okay, so we can say we have enough evidence to support the claim that the average expenditure per student has changed from $10,337. Okay, so it can be changed because we got this result. Reject H naught. Reject H naught means we have to reject this. So this can be correct. So you can, yeah, it's correct. This statement is correct. Yes, we wrote the same thing. We have enough evidence to support the claim. So this is our claim. So we can support the claim that the average expenditure per student has changed from this value. Okay. So that is our final conclusion. It should be very meaningful one. Okay.
Okay, that is all about this example tuition. Now we have new part. Now if we don't know sigma, that means sigma unknown, then we have to use another test statistic. Okay, so it's this. In here we don't have z, we have t. So you know this one also, we discussed about this in our previous chapter. So if you don't know the value of population standard deviation, then if you have to use this formula to find the test statistic. Okay, here you have s instead of sigma and here you have t instead of z. Then in this method you have to remember this one also. You have only one method, like normally we have two methods, critical value method and p-value method. We can use one of them to get our conclusion. But in here, if you don't know sigma, you have only one method. It is critical value method. Because p-value method is somewhat difficult when we have t-distribution. So we can't use that one. So definitely you have to use this method, critical value method, to find your critical values. And to get result, you have to use critical value method. Okay. Yeah, then what is this? Critical values in T distribution. Actually, you know how to find critical values. So I will not read these things because we already discussed in our previous chapter also how to find T distribution, how to find critical values in T distribution. Okay, but the special thing in this chapter is in here we have hypothesis test. So we can have one tail test, two tail test. But in previous chapter 7, we only have two tail test. Why? Because in there we have to find only confidence interval. But in this chapter here, we have left or right tail test, and we also have two tail test. Okay, so according to that, the method of the method of finding t critical value will be changed. Okay, but I will use these three examples to explain how can we do that. Okay, so then we don't need to read these slides, but if you want you can read. Okay, slide number 42 and 43. But this is slide number 44. Using these three examples, I will tell you how to find any t critical value. Okay.
This is slide number 44. Here the example is you have to find T critical values. Actually, you already know how to find T critical values because we did this in our last chapter, chapter 7. But there is a slight difference. In that chapter, we have to find confidence intervals. Okay, so in there, actually, we have only two tail like tests. It's similar to two-tail test. Okay, so I told you in there it's really good to use only what in T distribution. It's good to use only second row. If you want, you can use first row also, but if you know the alpha, then we can find corresponding critical value. But in this chapter, definitely you have to use either first or second according to your test. If you have a right tail test or left tail test, you have to use the first row. If you have two tail test, then you have to use second row. Because this is chapter 8, here we have to find hypothesis test. Okay, according to hypothesis test, you have two different types of test, one tail test and two tail tests. So according to those tests, the area, sorry, the row you have to select will be changed. Okay, now I will tell you how to find corresponding T critical values using this table A3. Okay, the first one is what? Here it's right tail test. Okay, you have to find the T critical T value for alpha is 0.05. This is right tail. That means one tail test. Okay, this is one tail test. Or you can write right tail, but anyhow it's about one tail. Okay, then we know degrees of freedom also. It's 11. Okay, these are the relevant details. Now use the table. Okay, this is very important. Okay, why? Because here we have one tail test. Okay, so remember, if you have a one tail test, I told you area is alpha is always in one tail. Okay, like here this second picture, the whole alpha is in your right tail. If it's right tail test, because first one is a right tail test, then your whole alpha significance level is in right tail. Okay, so from here you have to pick first row. That means area in one tail. Now tell me, what is the area in one tail? It should be alpha. According to our example, it's this. Our alpha is 0.05. Here it's one tail. I will draw the picture also. This is one tail, means actually this is it's right tail test. So we have to color only right sided area. Then you have to find this T value. This is T distribution. Now the area of this right sided part is what? It's alpha. Okay, alpha is 0.05. 0.05. Okay, now use the table. Area in one tail should be 0.05. Now degrees of freedom is 11. So pick 11 and this 0.05 from first row. Then what is the value? 1.796. Okay, 1.796. That is our T. I will write it here. Okay, I will write it again. T is equal to 1.796. Okay, it's very easy, but you have recognized what is your tail. Left tail, right tail, or two tail. Now, second one, we have alpha 0.01 and degrees of freedom is 22, and this is again one tail test, but here it's left tail. Okay, left tail test. Okay, then again use the table. Here it's something like this. This is the picture. I will draw the picture also. T distribution, middle is 0. Here it's left tail. So your significance level is in your left side. Okay, so what is the value of this point? You want to find that one. That is our T critical value. What is this area? 0.01. Okay, that is our alpha. Okay, now use the table. Again, you have to use the first row. Area in one tail, what is the value? 0.01. 0.01. Then what is the degrees of freedom? 22. 0.01 and 22. It's this 2.508. Okay, 2.508. This is the value, but please remember, this is very important thing. This is your T distribution. Middle is 0. Then you know definitely the left-sided values should be negative values. Right side, in first case, it's right-sided value. So it's positive. But here, it's left-sided value. But table only gives what? It only gives positive values, but it's okay. Why? Because this is a symmetric distribution. So using table, you can find only this value. It's okay, write it down, but please remember to put negative sign in front of your value. Okay, why? Here it's left tail test. So you will definitely have negative T critical value. Okay, please remember that. So in here, your critical value is negative 2.508. Okay, now the third example, alpha is 0.10, degrees of freedom is 18. Here you have, excuse me, two tail test. Okay, two tail test. Now, it's again very important. Now, it's not a one tail test. Now you have two significance levels. Okay, so this side we should be alpha over 2. This side also alpha over 2. Okay, then now use the table, the third picture. Here it is this. Okay, if you have two tail test, then in one tail you have alpha over 2 and other tail you have alpha over 2. So you have two critical values, negative critical value and positive critical value. Okay, but there is a symmetry of this distribution, so you can find one tail, then it will be same as other one, but you have to put the opposite side. But you know table always gives only positive T scores. That means only right-sided values. Now, okay, now our alpha is what? 0.1. Then what is our alpha over 2? You have divided by 2. The value is 0.05. So alpha over 2 is 0.05. Now here, actually here you don't need to divide. Okay, the thing is area in two tails. What is area in two tails? It's alpha. Okay, so it's 0.1. So using second row, select this one, 0.1. Then what is our degrees of freedom? It's 18. It's 18. 18 here. Area in two tails, 0.10, because our alpha is 0.10. So what is the value? 1.734. 1.734. That is our critical value, T value. Now this is symmetric one. Also it is two tail. So definitely there is another critical value in other side also. It will be same as the right sided one, but you have to remember if it's left side, you have to put negative sign. So in third case, we have two critical values. What are those values? Negative 1.734 and positive 1.734. Okay. Okay. So these are okay. These are my two critical values for third example. Now you know how to find critical value if you have a right tail or left tail or two tail test. Okay, actually here you don't need to find alpha over 2. Okay, if you want, you can find. Why? Then if you want, you can use actually first row also. Then area in one tail should be 0.05. Can you see? It's same because we use, if it's two tail test, just use second row. Area in two tails, it should be your alpha 0.1. But can you see, you have to pick the same column, but you can use first row. Yes, but if you use first row, then the corresponding alpha for 0.10 is the half. It's 0.05. Okay, so this is correct, but if you want, you can find alpha over 2 and you can use first row, but don't need to do that. If it's two tail, just pick alpha, then use second row. In there you can find just alpha, then using degrees of freedom you can get the value. It's 1.734. okay.
Okay, then yes, now you know how to find T critical values. Now we have two examples. This is the first one. Now I will show you how to find these values, okay, how to get the answer. The first one is substitute salary, slide number 45.
This is slide number 45. Example is substitute salary. First read the question carefully. An educator claims that, okay, this is our claim, that the average salary of substitute teachers in a certain county in Pennsylvania is less than $60 per day. So that is our claim, okay. The salary is less than $60 per day. So first write down the hypothesis. Here it's H0 versus H1 null alternative hypothesis. Then what is this? It's about average, okay, not proportion. If it's about average, you have to write mu as your population parameter. Here equal always goes with null hypothesis. Then what is the claimed hypothesized value? The hypothesized value is it's 60. Why? Because in the claim it's asked to find is less than 60. So here we have the keyword less than. Less than means this less than symbol. Okay. So what is this test? This is left tail test. Okay. So this is our hypothesis. Then the next thing is, okay, read continuously. Then a random sample of 8 school districts. So what is our sample size? N is 8. School districts in the county had an average daily salary of X bar is 58.9 and standard deviation of that sample, that means simple S is 5.1. Very important thing. Why? Because in here you don't know the population standard deviation. We only know sample standard deviation. I told you if you don't know sigma, you cannot use the previous test statistic formula for mean. Okay, you have to use the T test statistic formula to find the test statistic. Okay, that formula is in slide number 41. Okay, use that formula 41. I will write the formula. Why? It's about it's T formula. Okay, why? Because we don't know sigma, we know only S. So T is what? X bar minus mu divided by S over square root of N. Okay, the only difference is here we have S. In previous test statistic formula for mean, we had Z and sigma. Now we have T and S. Okay, now substitute values. What is our X bar? It's 58.9 minus what is our mu? It's 60. Then what is our sample standard deviation? It's 5.1. What is our n? It's 8. Take the square root. So what is the value of t? Using calculator, you can find this value. Our test statistic is this. Okay. Now, what is next step? The step of hypothesis test is you have to use either p-value method or critical value method to find p-values and critical values. But please remember, this is our method with sigma unknown. Okay. If you don't know sigma, you have to use t. Then if you have to use t distribution, then it's somewhat difficult to find p-value. Okay, so we only use a critical value method to get our final results. Okay, so there are no two methods. Okay, you have only one method. You have to do this. Okay, anyhow, if you like or not, you have to use this method. What is that method? Critical value method, because p-value method is somewhat difficult. It's not you cannot actually, it's not related to this course, so I will only teach critical value method. Okay, so using this method you can get the solution. Then you know how to find critical values. If you know alpha, we can do that. First, draw the curve. Here it's left tail test. Okay, then remember, I told you if it's left tail, this is t distribution, then you have only critical region in your left tail. Okay, because it's left tail, so you have only left sided area as your critical region. So this is our critical region. Then what is the value of this region? It is our alpha significance level. Here it says alpha is 0.10. So what is the value of this area? 0.10. Okay, actually now this is about t distribution. Okay, so remember I told you how to find critical value. If you have alpha, I will write it here again, alpha, and if you know degrees of freedom, you can find critical value. Degrees of freedom means n minus 1. Here n is 8 minus 1. It's 7. So now we know alpha and degrees of freedom. So you can use the table. Here, what is our alpha? It's 0.1. It's only in our left side. Okay, here left, it's a left tail test. So definitely your t value should be negative value. But first find the value. Alpha is 0.1. This is one tail test. Okay, area in one tail should be 0.1. Area in one tail should be 0.1. That is the last column. Degrees of freedom is 7. 7. So what is the corresponding t value? T critical value is this 1.415. Okay, this is the value we got from the table, but remember table gives only positive values. So if you, here it's negative value because we have left tail test, so put negative mark. Okay, minus. Okay, now this is my t critical value. Okay, okay, I will write it again. I will write it here. So what is our critical value? It's negative 1.415. Okay, now the thing is this. We know our test statistic and we know our critical value. Now mark this test statistic in your curve. Okay, it's negative 0.61. It should be in here, negative 0.61, because here it's negative 1 point, so it should be in here. So what can you say about this? Can we reject? No. Why? Because it's in acceptance region. Okay, it is in here. So we can say, we cannot reject H0. So we have to write fail to reject H0. Fail to reject H0. This is our result. Okay, now okay, I will write this solution result as a sentence. Okay, meaningful sentence. What is the corresponding sentence? We can write this way. Okay, it's fail to reject. That means H0 is correct. This will be wrong. So this is the thing. So we can write we don't have we do not have enough evidence to what? We don't have enough evidence to support the claim. Support the claim that substitute teachers in this country, that in that country are paid less than $60 per day. Okay, that is the conclusion. It's very simple. You have to understand what is your result. It's fail to reject. So we cannot say H1 is correct because we fail to fail to reject H0. That means this is wrong. Okay, alternative this is wrong because we cannot reject H0. So fail to reject means H0 is correct. So null is correct. So we don't have enough evidence to support the claim. We don't have enough evidence to support the claim that the substitute teachers in that county are paid less than $60 per day. So that is the conclusion, okay, for this example, substitute salary, okay.
Okay, that is about this example. Then our next slide number 46. This is our last slide of this chapter and this course. Okay, last slide, it is the example infections. Now I will show you how to do this example also.
Okay, this is slide number 46, the last slide of this chapter. Example is infections. First read the question example carefully. A medical investigation claims that, so this is the claim, that the average number of infections per week at a hospital is 16.3. Okay, we have the claim. So write down the hypothesis. This is always about what? Average. So it's about mu, okay? Equal mark goes with null hypothesis. What is the value? Hypothesized value. It's 16.3. Here also it's 16.3. But what we have to write here? Can you see any keyword like less than, greater than, increase, decrease? No, it just we want to claim that the average number of infections per week at a hospital is 16.3. So we don't know it is increase value or decrease in one. So you have to use not equal mark. Okay, so this is our hypothesis. Then read a random sample of 10 weeks. So what is our n? It is 10. 10 weeks had a mean number. So the mean number of that sample, that means we have x bar is 17.7. And the sample standard deviation, we have simple s. Sample standard deviation is 1.8. Very important, we know only s. We don't know sigma. So again, this is sigma unknown case. Then second step is you have to find the test statistic. Here you have to pick this formula. Why? Because you don't know your population standard deviation. So use the t test statistic. In here you have t and here you have s. Now you have the values. So substitute. What is x bar? It's 17.7 minus what is mu? 16.3. What is s? 1.8. What is n? 10. Take the square root. So what is the t value? Test statistic. It's 2.46. Okay. Now we have the test statistic. Then next thing is what? We have only one method. Okay. It's what? Critical value method. Okay. In here, it says our alpha is 0.05. Now we have what? I will draw the curve. We have two-tail test, okay? Then middle is 0. Then we have two tails. Alpha is 0.05. Then if you want to get the critical values, you need degrees of freedom also. It's n minus 1. 10 minus 1 is 9. Now we have two-tail test. So one side is alpha over 2, other side is alpha over 2. But you don't need to find alpha over 2. Just pick the value of alpha. Why? Because table have that row. In second row, it says area in two tails. So tell me, what is the area in two tails? It should be alpha. Here it's 0.05. So in second row, you have to pick this value, 0.05. Area in two tails, 0.05. Then what is our degrees of freedom? It's 9. So here it's 1, 2, 3, 4, fourth column. Then degrees of freedom is 9, okay? So this is 9. So this is the value. Area in total is 0.05. Degrees of freedom is 9. So 2.262. 2.262. 2.262. It is this value, positive t value, t score. Then what is this value? Same value, but you have to put negative sign. Why? Because this is symmetric. Now these two values are our critical values. I will write it again. What are the critical values? Negative 2.262 and positive 2.262. Okay, now we know what are the critical values. Then mark your test statistic in here, in this graph. It's 2.4. Here, 2.2. Our test statistic is 2.4. 2.46. So can you see? It is in here, inside. It is in your what? Critical region. It is in your rejection region, okay? So it is in your rejection region means we have to say what? Reject H naught. So the answer is reject H naught. Okay, this is the answer. So how can we convert this into sentence?
Okay, actually, my baby was crying when I record that part. Okay, so I will not play this one, and I will show you how to write our interpretation using this. Okay, using this Word document. This is the interpretation. I will show you. We actually here we reject H naught, so that means we have enough evidence to support the claim that the average number of infections per week at the hospital is not equal to 16.3. Okay, so this is our interpretation. That reject H naught means we have enough evidence to support the claim. Okay, in here our claim is alternative hypothesis. Then here I just write the sentence that it is from our question. Okay, so that the average number of infections per week at the hospital is not equal to 16.3. okay, so it's very simple. So that is our final conclusion, interpretation. Okay, now now that is all about this slide. Actually this is our last slide. So this is our last slide in our this course. Okay, now if you have any questions about these chapters and anything, you can email me. Okay, let me know, then we can talk about these things. Please go through all the video clips. Okay, thank you.